We're going to solve the price elasticity of demand from this demand equation. The market demand is given by the following. We want to solve for the price elasticity of demand at a price equals $1. Here is our elasticity of demand formula. There are three things. There is the derivative of the demand equation with respect to its price. Then we multiplying that by the ratio of price to the quantity demanded. So first, let's talk about the derivative of a natural log, since we have a natural log here on the right-hand side. So here's the general rule. Let's say y equals the natural log of a function g of x. So here's the derivative. We take the g of x function, move that into the denominator. Then we take the derivative of the g of x function, and that is placed in the numerator. And that's it. 2 steps. So the derivative here of the demand equation with respect to price, we take this p term, move that into the denominator. That would be the g of x in this case. Then we take the derivative of p, which is just 1, and that 1 is being multiplied by the minus 2 in front. And so we have our derivative result. So let's put everything together. We have our derivative result, minus 2 divided by p, and then that's going to be multiplied by the ratio of price to quantity. And something neat happens here. You can see that the price terms cancel, and we have elasticity of demand of minus 2 divided by q. So what do we put in for q? Well, we could do this. If p is 1, let's evaluate the demand equation, and we get 200 for q, so we'll plug 200 in for q. So minus 2 divided by 200, we have elasticity of demand of minus 1 over 100. Another example. Here's elasticity of demand, 500 minus 40 times the natural log of p. Solve for the price elasticity of demand at q equals 20. So the derivative of the demand equation with respect to price, it's following our rule before. The p comes down into the denominator. The derivative of p is 1, and the minus 40 is out in front, so we get minus 40 divided by p. Multiplying that by price times quantity, where the quantity is 20 this time. The p's cancel, and you're left with minus 2. And another example. Solve for the price elasticity of demand when q equals 5. So we get our derivative of the demand equation with respect to price. So the 5p gets moved into the denominator. The derivative of 5p is just 5, so that's in the numerator. But you'll see that the 5's cancel, and we're left with minus 1 divided by p. Multiplied by p divided by q, where q is 5, we just get minus 1/5, or minus 0.2. And in our last example, we want to figure out what price the price elasticity of demand is minus 1. So in other words, we want this elasticity of demand formula to equal minus 1. So we take the derivative of the demand equation with respect to price, and we get minus 1 divided by p. And as before, the price terms cancel, getting rid of the minus sign on each side. We have q equals 1. And when q equals 1, we're going to evaluate the demand equation. So we're going to plug in 1 for q. And now we're going to solve for price. And exponentiating both sides of the equation. The left-hand side will just be p. And that'll equal e raised to the 3rd power, which is roughly $20.09. So if the price is $20.09, the price elasticity of demand will be minus 1. All right, I'll stop here.